Hi, my name is Elrid Serrao, and today I will be showing you the work I've done in Lab 1 entitled Charged Tapes. In this lab, we are studying electrostatic repulsion and attraction, which are the results of electric forces caused by the interaction between two or more charges. We can investigate this phenomenon knowing that pulling apart pieces of tape will give the tapes a charge. Knowing this, making a few assumptions about the tape, and knowing about the fundamental laws behind it, I can determine information about the charge, which I've determined to be 7 times 10 to the negative 9th coulombs in this experiment. In this presentation, I will be going over the experiment, necessary calculations to draw conclusions from the experiment, and a program modeling the experiment. Some useful equations explaining these laws quantitatively include the equation of an electric field, the equation of an electric force, and the equation of a gravitational force on Earth based on Newton's second law. And in this experiment, we are assuming each charged tape has the same charge because they are the same sized and were pulled apart from the same tape. Each charge is located at the center of each tape, and when the tape is floating, there is no movement on the XZ plane. Initially, I measured my tapes to be 20 centimeters, and, assuming the density of tape is 1 gram per meter, I determined the tape's mass to be 2 times 10 to the negative 4 grams. To determine the sign of the charge, I hung a charged tape and held a pencil that I rubbed on my hair, knowing that it would create a negative charge to the tape. As seen in Figure 1, the pencil was attracted to the tape, so I know the tape's charge was positive. In Figure 2, you can see the setup for how the charged tape was suspended. When I held another charged tape under it, the electrostatic repulsion occurred around 1.5 centimeters. At this point, the magnitude of the gravitational force equals the magnitude of electric force, which is useful when determining charge. Using the mass of the tape and gravitational acceleration on Earth, I calculated the gravitational force and set that equal to the electric force. Since we know D, we can calculate charge, and this charge agrees with the expected electric force and gravitational force to make the net force 0. Some additional things I calculated was the number of atoms that compose the tape, using the area of the tape, and the number of electrons that were given up by these atoms by dividing the excess charge by the charge of an electron. Using this, I determined the ratio of atoms that gave up electrons during the charging process. I then modeled this experiment using VPython. Here, I represented the two tapes using 2-point charges 1.5 centimeters apart from each other, and defined constants and a function to calculate electric field. The force of gravity was calculated from Newton's second law, and the purple arrow represents the magnitude and direction of this force. Knowing that Fe and Fg are equal in magnitude, we can set them equal to each other and solve for Q, knowing that there is no force on the XZ plane. The first line in this code goes through the algebra of doing this and relies on the assumption that the two tapes have equal charge. We can then calculate Fe, which is just the opposite in the opposite direction of Fg, as shown by the yellow arrow. If the charge of the electrons and protons flipped, no change would occur in this experiment since the magnitude of the charge stays the same. If I was to touch the tape too much, the charge would escape into my hands, so it was important to minimize my contact with the hands and other conductors. In summary, this lab allowed me to use household objects to determine information about some of the fundamental principles governing electrostatics. Secondly, I used the data I gathered and knowledge about the gravitational and electric forces to determine electrostatic properties. And finally, I learned how to use Python to simulate the interaction between charged particles. Thank you for listening to my presentation, and have a nice day.